Hello everyone, my name is Pinchao Liu. Today I'm going to present our work which is named SR3 Customizable Recovery for Stateful Stream Processing System. This work we have our co-authors as Hailu Xu, Susana Cruz-Diaz, Dilma da Silva, and our advisor Li Tinghu. The Professor Dilma da Silva from Texas A&M University. Other co-authors are from Florida International University. And we are from the research lab, which is named ELVES Research Lab. And this work is supported by the NSF funding. So firstly, I will introduce our research work's background. It's related to the stateful streaming application. So the modern stream processing applications need to store and update states along with their processing and process live data streams in a timely fashion. So they run in a dynamic distributed environment. Meanwhile, their workload may change in unexpected ways, and multi-stream operators can be failed at the same time and cause the state's loss. So to explore the customizable state recovery mechanisms for protecting large distributed states in the stream processing system is one of our main targets for this research paper. And to cater to the needs of different stream processing applications that have different stream processing computation mode, state size, and network environments. There are several challenges. Currently, so here we name two main challenges for this research work. The first one is how to recover from simultaneous failure of multiple stream operators for many concurrent running applications. And this scenario is same as the real world scenario. So the second challenge is how to customize the failure recovery mechanism for different type of stream processing applications. So this is the proposed system design of SR3. So it is a layered design. So in this, from the right figure, we can see we named 4 layers for this designed system. The bottom one is the DHT-based overlay. So DHT stands for distributed hash table. So as you can see, we form these physical servers into the DHT-based overlay network. In this network, the relationship of each node is a P2P. So it's a peer-to-peer. So we use this ring overlay to present this P2P relationship between different servers in the network. The layer 2 is the state partition and replication. So we separate the states into the partitions and the replications, and including the mechanisms for different recovery ways. So the top level is the layer 4. We name it as SR3 APIs. So we provide this API to the users to use this framework in order to have the function to recover the states and manage the states. As we mentioned, that it's hard to provide just one single structure to cater to all the complicated scenario in the real world. So in our paper, we present 3 of the structures. The first one is called a star structure, and this is the most straightforward way. So there are some benefits for this design. The first one is the recovery process is fast because we can find these states parallelly and form them into the recovered one, as this picture showing. And then we also can achieve data locality because the leaf side contains nodes that are geographically close to the original node. So there is less network overhead caused by this design. So the second one we are presenting, the structure is named the line structure recovery. So for the previous star structure, we back to this star structure. There is a, as you can see, if you notice that actually we have a central point here. So it's hard to recover for large state by using the star structure. So we propose this line structure, and the benefits for this structure is that the downloading and the computing load are well balanced among all the involved nodes. And then by using this recovery mechanism, we can avoid the central bottleneck. The third one, we call it the tree structure. It has a spanning tree that is built on top of the scalable application multicast infrastructure, and this multicast is one of the function property of the DHT overlay network. And the benefits are a providing node only need to upload some of the shard it stores. So that means in each, as this picture showing that for each node, they just need to provide a partial of the information it stored. And meanwhile, it has the attribute that the downloading and computing loads are well balanced among all the involved nodes. So we built this system based on two open source framework. One is the Apache Storm, and the second one is the Pastry. Pastry is in charge of the DHT overlay management, and we provide these APIs to users to use our designed framework. So you can go through these detailed APIs from our paper. And then I will go through the evaluations to answer the following questions, such as the performance for the performance improvement for the state save and recovery, the flexibility and the scalability for the proposed system, and the overhead for SR3. Firstly, we will see the time of the state save and the recovery compare our SR3 mechanisms with the state-of-art, the checkpointing mechanisms. So SR3 generally can obtain 30 to 60% less state recovery time. Secondly, we check the state recovery time with different number of failures. So the x-axis is the failure numbers, simultaneous failure numbers. So we can see the two curves just for the recovery time just has a slightly increasing with the within the along with the number increasing of the shard failure. Then we consider this evaluation regarding to the load balance and scalability. So SR3 has the attribute for load balance property because it distributed states across all the nodes in the overlay network. So from these three figures, we can see that the first two is related to the nodes distribution. In the overlay network, we have this 5,000 nodes. You can see they evenly distributed the shards over the servers in the overlay network. And the third figure is related to the normal probability for the recovery for the deployed states on the overlay network. The last one is the overhead comparison between this SR3 method and the checkpointing methods. So we can see for CPU and memory usage or overhead, the proposed SR3 has less resource usage. For the network traffic, it has increased network traffic when the nodes increasing in the data center because it needs to have this ping-pong message keep going to maintain the DHT overlay network. So in this paper, we conclude that firstly, we show the existing techniques that lead to a slow or resource expensive state recovery. And then we propose this SR3, and it has 3 mechanisms to cater to a different kind of scenarios for the state recovery. And we also present the integration of SR3 onto Apache Storm framework. Finally, we make a comprehensive evaluation for the scalability, fast recovery, and flexibility of SR3. And there are some detailed design and implementation and evaluation that we demonstrate in the paper. If you are interested, we encourage you to read our paper. Thank you so much.